Internal resistance question 1. State and explain whether a school high voltage power supply should have a low or a high internal resistance to make it safe. The internal resistance should be high. This limits the maximum current that the supply can provide. A cell of e.m.f epsilon and internal resistance R is connected to a resistor of resistance capital R and passes a current I. Write down an expression for the power dissipated in the internal resistance. Well, power is given by I squared R, so in this case the power will be I squared times little r, the internal resistance. Write down an expression for the power dissipated in the external resistance. Well, this will just be power is equal to I squared capital R. Write down an expression for the total power produced by the cell. Well, this will be given by the current times the e.m.f of the cell. Write down an expression based on the law of conservation of energy and use it to show that this expression holds. Well, if I copy the expressions from previously, the power dissipated in the internal resistance was given by this, the power dissipated in the external resistance by this, and the total power by this. So in terms of the law of conservation of energy, the total power must be equal to the power in the internal resistance plus the power in the external resistance. And if I substitute for the other expressions, I get this. I can cancel throughout by I to get this expression, which can then be rearranged to give the required expression from here. Explain how this equation shows that the maximum current available is limited by the size of the internal resistance. Well, the maximum current would be when the supply is short-circuited, i.e. when the external resistance is 0. The current would then be given by epsilon, the e.m.f of the cell, over little r, the internal resistance of the cell. The smaller the internal resistance, the bigger the maximum current will be.